Welcome to the deep dive. Today we are taking a really granular look inside what you might call the engine room of scientific and technical practice. We're talking about product research and development, or R&D.
Mm-hmm.
I mean, if the engineering and geoscience professions are all about solving problems, R&D is really the forge. It's where those solutions are actually made.
It absolutely is.
So our mission today is to unpack how exactly scientific principles and all that technical expertise get systematically converted into real tangible products that deliver value. We're going to focus on the critical role that licensed Canadian professionals play in this whole cycle.
And this is such fundamental knowledge, especially for those of you who are preparing for professional practice. R&D, it defines how these professions contribute directly to public welfare, to our national economic growth, and this is the crucial part, how they uphold the ethical and safety standards that underpin everything.
Right.
It's really the application of knowledge, not just, having it.
Okay, let's unpack this. And because this information is so foundational to professional integrity and success, especially if you're studying for the NPPE exam, we design every deep dive to synthesize these complex ideas. So to make sure you don't miss our next discussion, please subscribe to the deep dive right now. It'll ensure you get more of this expert analysis and these critical insights, all aimed at helping you successfully prepare for that exam. Now, back to R&D. Let's start with the basics, the definition. We often think of R&D as this kind of light bulb moment, but it's far more systematic. So what exactly is the structured process of product R&D?
Well, at its core, it is a systematic process, and that's the key word. It's about creating, improving, and refining products, whether they're physical or digital.
Okay.
The systematic part is what matters because it's this combination of, let's say, pure scientific discovery with a really rigorous engineering design methodology.
So it's not just random tinkering.
Not at all. The goal is always to meet a specific identified user need or to solve a very defined technical challenge. You can think of it as the translation layer, where pure knowledge finally gets its market and societal utility.
I like that. That concept, converting knowledge into value, that's really the high-stakes outcome here, isn't it?
It is.
We're talking about huge social returns, advanced materials that make our infrastructure last decades longer, or next-gen medical devices that are literally saving lives, or even those sophisticated environmental monitoring tools that help guide public policy.
Absolutely. And in the Canadian context, successful product development strengthens our competitive position on a global scale. We're not just talking about local impact.
Right.
When Canadian developed technology, things like specialized components for the KMD reactor system or certain mining automation software, when that gets adopted internationally, R&D becomes a massive economic driver for the whole country.
Okay, so to manage all that complexity, the process has to be disciplined. You can't just wing it. We view it as a clear, structured life cycle, almost a roadmap that professionals have to follow. We've broken it down into 6 key stages.
And the first stage is probably the most crucial, ideation and problem identification. Before you build a single thing, you have to accurately define the problem.
Is there a real need for this?
Exactly. Is there a genuine societal or market need? And this often requires a huge amount of background research just to understand the landscape you're working in.
And once you've got that need identified, you move into stage 2, which is concept research.
The feasibility phase.
Yeah. This is where professionals study design principles, the potential impact, all the constraints like cost and resources, and just, is this idea even technically viable based on what we know right now? This is where you might rule out the impossible before you waste time building the improbable.
Which leads you right into stage 3. Prototyping and development. This is the fun, creative stage where you finally move from theory into reality. You're creating experimental models, maybe building a minimum viable product, and just rapidly iterating on those early designs.
And the quality of this stage fundamentally impacts everything that comes after, especially the professional liabilities.
That's a great point. Because once you have that prototype, you move into the stage that is most directly tied to professional judgment and accountability. Testing and evaluation. This isn't just a suggestion, is it?
No.
Not in the slightest. Stage 4 is basically the verification firewall. You have to rigorously, and I mean rigorously, verify functionality, durability, and safety, and you have to confirm absolute compliance with all the applicable regulatory standards. This is where your professional accountability for public safety is really put to the test.
Okay, so only after that firewall, then what?
Only after a successful evaluation can we even think about stage 5. Commercialization. This means scaling up production, developing robust supply chains, and formally introducing the product to the market. And that requires a whole new layer of business and regulatory oversight.
But it doesn't just stop when the product is sold, right? There's a final stage, continuous improvement.
Hmm.
How do professionals balance that ethical duty of making a durable, lasting product with the market pressure to just constantly innovate and release the new version?
Yeah, that's a real point of professional tension. Continuous improvement demands that you incorporate real-world performance data and user feedback into the product's next version. It reflects an ongoing commitment to optimization and to safety.
Hmm.
This stage ensures long-term viability, but ethically, it means you can't artificially limit a product's lifespan just for profit.
Here's where it gets really important for the learner. Who specifically is driving all this innovation? What are the unique roles of licensed engineers and geoscientists in bringing these products to life?
Well, engineers, across all the disciplines, they are the primary transformers. They take theoretical ideas and turn them into practical, manufacturable, and sustainable products. And just consider the breadth of it.
Yep.
You've got mechanical and civil engineers designing everything from high-efficiency heat pumps to complex bridge components. Then you have electrical and software engineers developing the microprocessors, the control systems, the software that just defines all modern technology.
And we can't forget the material science innovators.
Yeah.
I mean, chemical engineers are crucial for optimizing industrial processes, developing new sustainable fuels, and engineering advanced materials that are lighter, stronger, or more resilient.
Right.
And then you have biomedical engineers developing prosthetics, diagnostic equipment, assistive technologies. It's this amazing blend of biology and the mechanical design.
And the contribution of geoscientists is just as unique. It's often tied directly to environmental sustainability and how we use our resources. They don't just find resources, they develop products derived from them,
Like what?
like specialized minerals used in battery technology or advanced filtration media for water. And crucially, they design and use these incredibly complex analytical instruments for environmental data collection and monitoring.
So their involvement is essential. It's their deep understanding of the Earth system that ensures all this product innovation is aligned with sustainable resource use and environmental protection.
Yeah,
They're the ones connecting R&D directly to long-term stewardship.
exactly.
Let's pivot for a second and connect R&D to the broad economic and societal benefits. Because this isn't just about technical papers in a lab, it's about shifting global markets and changing people's daily lives.
The economic impact is, well, it's dramatic. R&D fuels economic growth by creating entire new supply chains. Take electric vehicles, for instance.
Mhm.
Developing EVs didn't just create a car. It required these multi-billion-dollar R&D efforts in battery tech, charging infrastructure, new materials processing, and that created thousands of specialized jobs and boosted Canadian export capabilities.
And you can see how that translates into tangible improvements in our quality of life. Think locally. It's the development of safer, seismically resistant building materials that protect communities in earthquake zones.
Yeah.
Or, considering community needs, it's the design and rollout of clean water filtration systems that are specifically tailored for remote or indigenous communities, addressing public health issues that have been around for far too long.
And we also see a huge impact in assistive technology for people with disabilities, which ensures accessibility and independence. On top of all that, the commitment to sustainability is now paramount. It's not an afterthought anymore.
Right.
Products are increasingly designed not just to work well, but to minimize their environmental harm, using less energy, maximizing a product's life cycle, and designing for efficient disassembly and recycling.
That commitment to safety and compliance brings us back to what you call the firewall meeting standards. Professionals have to adhere to these really stringent requirements from organizations like the CSA, the Canadian Standards Association, and ISO, the International Organization for Standardization. What do these groups actually demand?
They provide verified, repeatable processes for safety, for quality management, and for performance. And compliance isn't optional. It's the very basis of your professional license.
Okay.
For example, CSA standards often dictate the acceptable performance and stress limits for infrastructure components or electrical equipment used in Canada. They're there to ensure public safety.
So the testing required in Stage 4 must be pretty intense.
Oh, it's extensive. It covers stress and performance tests, comprehensive environmental impact assessments, and rigorous quality assurance evaluations. And here's the key. Failure to meticulously document these tests or trying to hide negative results. That's where professional liability and misconduct really intersect.
That's a critical distinction. It's not just about a test failing. It's the ethical responsibility you have around reporting the test results, that matters most.
Precisely. If a professional fails to rigorously document those tests, or if they say misrepresent a product's capabilities just to rush it to market, that leads directly to serious professional misconduct. If that product later fails and causes harm, honesty and integrity in reporting are just foundational ethical duties.
And to see the high watermark of this rigor, we have some incredible Canadian R&D success stories. The Canadarm is the obvious one.
Oh, classic, yeah.
It's just this brilliant fusion of precision mechanics, robotics, advanced material science. It's a showcase of collaboration on the global stage.
And, often less visible but just as transformative are the innovations in heavy industry. Canadian R&D really pioneered advanced mining equipment, developing autonomous drilling and haulage systems.
Hmm.
This didn't just boost efficiency. By removing human operators from inherently dangerous places, it fundamentally revolutionized worker safety in a really high-risk sector.
And let's bring it back to those local solutions again. The development of portable, sustainable water purification devices. These are designed for deployment in remote communities or areas hit by disasters. These, lower profile innovations have a massive societal footprint across the globe.
Absolutely.
So we have to shift focus now to the ethical guardrails that are required throughout this whole process. The technical work always has to be managed responsibly, especially with how fast technology is accelerating.
Right. So beyond the integrity and reporting that we just talked about, the primary duty is public safety. Professionals have to rigorously test every component to prevent harm. I mean, just think about defective medical devices or faulty structural materials. Those failures don't just cause harm, they destroy public trust, and they constitute severe professional negligence.
And what about that idea of stewardship?
Well, there's also the crucial ethical commitment to sustainability and stewardship. Professionals have to consider the full life cycle impact. Where are the raw materials from? How much energy is used during manufacturing? And what happens at the end of its life? Can it be disposed of responsibly or recycled? Designing for a better planet is now just an intrinsic part of ethical R&D.
That raises a really interesting point about the future. If ethical stewardship is so key, what are the emerging trends that professionals need to be watching out for? What's fascinating here is how quickly technology is changing the entire landscape.
Well, the digital revolution is fundamentally reshaping the design phase. Artificial intelligence and data-driven design, they're becoming mission critical.
How so?
AI allows engineers to run thousands of performance simulations to optimize material selection and to predict failure points before a physical prototype is even built.
Wow.
It massively speeds up innovation while at the same time improving the safety modeling.
And that connects directly to additive manufacturing or 3D printing, which is just accelerating the prototyping stage dramatically. Especially in high-precision fields like aerospace or specialized medical implants, it allows for customization that was never possible before.
And finally, there's the continuous push in advanced materials R&D. We're talking composites, biomaterials, nano-engineered components. These are leading to products that are stronger, lighter, more durable, which is essential for maximizing efficiency in everything from, say, wind turbine blades to the next generation of transport.
That has been a very comprehensive deep dive into the structured, high-stakes world of product R&D.
I think the core conclusion is this. Product R&D really embodies the professional commitment to apply specialized knowledge for the public good. It's inherently interdisciplinary. It demands collaboration across all these different fields while managing constant challenges, like funding constraints and the ever-changing regulatory landscape.
So what does this all mean for you, the learner? The sheer breadth of R&D, from the complex robotics of the Canadarm all the way down to the critical simplicity of a sustainable water purifier, it illustrates the essential connection between your technical knowledge and human flourishing. Your future role is one of immense responsibility, but also immense impact. And that leads us to a final provocative thought. Given this rapid integration of AI and data-driven design into product development, how do professionals ensure that the ethical duty of public safety and rigorous testing keeps pace with the acceleration of these new design technologies? How do we verify the safety of a product that was designed by an algorithm? That is a question every future professional really needs to consider carefully. This deep dive provides the essential, synthesized knowledge that you need for professional practice. To ensure you stay informed, successful, and ready to tackle that NPPE exam with confidence, please subscribe to the deep dive right now. We look forward to guiding you through your next complex